This is my project requirements testing video, starting with requirement 1, have a menu that gives options to create a new circuit or exit. When we run the program, here is the menu, here are the two options. By left-clicking on exit, you close the program, and by left-clicking on new circuit, we create a blank circuit. Requirement 2, user able to switch back and forth between circuit and menu and other interfaces. Here we are on the circuit, and if we press the escape button, we return to the menu, and if we press the backspace button, we return to our circuit. Requirement 3, have a help button that instructs the user how the software works, explaining the controls, etc. If we return to the menu, you see the help button here. By left clicking on that, we have all the instructions on how to use the program. And looking back to requirement 2, if you press the escape key again, you return to the menu. Moving on to requirement 4, user able to make a circuit with any of the following components by dragging and dropping: inputs and or not and SAW gates and outputs. Simply go to the circuit, and here are the components on the left hand side, and we just left click to select and drag and release the left click where you want to place, and you can do this with all the components. Place them wherever you want. Requirement 5, users should be able to connect components with lines representing wires. To do this, simply right click on the component and then right click on the second one to create a connection. Show state on or off in wires, inputs and outputs using color. As you can see here, as the switch is powered, it is green. As the wire has power in it, it is blue. And as the bulb is powered, it is yellow. And when they are not powered, they are black and white. When connected components are moved, the wire must also adjust. As you can see here, when we move this or we move this, the wire adjusts accordingly. Each gate should have the correct available input and output options, e.g. an AND gate has 2 inputs, a NOT gate has 1 input, and a switch has 0 inputs. As you can see here, if we add another switch and try and connect it to this bulb, a connection is not made because there is only one available input in the light bulb and it is already taken. With the AND gate, we can connect 1 and 2 both to that, but not a third. And with a NOT gate, the same applies. You can connect 1, but you cannot connect another. And the same applies for the rest. They all have the correct amount. I thought I would just demonstrate 2 more restrictions on what connections can be made based on input and output ports. An bulb cannot be connected to another gate as it does not have an output port, and nothing can be connected to a switch as it does not have an input port. Objective 9, users should be able to connect an output to up to 2 inputs. Here we can see a switch and 2 bulbs. We can connect that to up to 2 there. User should not be able to connect a component to itself. As you can see here, if I click on this and click it again, no connection is made. If there was a connection made, the wire would loop around and go back. And as you can see, that's not happened because a connection has not been made. Users should be able to delete components, also deleting any existing connections between this component and others. To do this, simply hover over and click the delete button on your keyboard, and as you can see here, the component is deleted, as are the connections. To delete all, users should be able to go back to the menu and create a new circuit. We simply escape and then click new circuit, and as you can see here, all the components have been deleted. Each gate should perform their expected Boolean operations, taking the input states to create an expected output. Okay, so we are going to start with an AND gate, connecting 2 switches and connecting it to an output, and as you can see, when both are on, it outputs an on. When one is on, it outputs an off, and this works for either, and when both are off, it does not output anything. Here we have an OR gate, and when we connect both to the OR gate and to a final output, here you can see that when both are on, it is on, when one is on, it is on, when both are off, it is off. Here is a NOT gate, and as you can see, it reverses the input. Here we are inputting 1 and outputting 0, and when it is 0, it is outputting 1. Here we have an XOR gate, and when both inputs are on, we output the 0. when one is on, it outputs a 1. When both are off, it outputs 0. I thought it would be a good idea to show an example of a full circuit with multiple gates and multiple inputs, all leading to a final output. And here you can see that this is a NOT gate and an AND gate connected to an OR gate. So either this is off, which turns it on, or both of these are on, and it still turns it on, or both are true. But if that is on and these are both off, then it is not powered. Moving on to objective 15, as already demonstrated, these change when toggled. Moving on to objective 16, be able to convert a circuit into a truth table where each connected component is displayed and assigned a letter, which will also be shown when the circuit is drawn. As you can see here, all the components are assigned a letter based on the order in which they were placed. And if we click on the truth table, here we have the inputs, and it cycles through all the states combinations of on and off, and here are the states at every gate, and then finally at the output. I thought I would show you another example of a truth table with a different circuit. This time it is just 2 input switches connecting to an AND gate which connects to a light bulb. This will be a very simple AND truth table. I also included a gate that is not connected to show what happens to that in the truth table. And if we click on the truth table generator, we see that the non-connected gate is not present. Here we have our inputs, and it cycles through those with all the different combinations of inputs and records the state at each one, which is as expected. Moving on to the desired objectives, we have a customizable color scheme for the application. For this, you can go to settings and you can change the background color. You can change to black, variations of gray, any of these colors here simply by left clicking on the color you want, and it will keep that for when you go to your circuit and when you build. The desired objective number 2 was NAND and NOR gates. These could be made by simply connecting an AND gate to a NOT gate, but I did decide to make separate gates with those as well, and you can see here the logic for that is the inverse of a normal AND gate, which is when both are on, it is off, but with any other option, with any other combination, they are on. And for a NOR gate, the logic is the same. It is a reversed OR gate, so when one is on or both are on, it is off, but when both are off, it is on.